Okay, good morning, class. In continuation to our last week's topic, we are going to be solving more examples on equation. And here on this slide, I have an equation that it's in your textbook, but I'm going to explain as we go further. Now we have 25 minus 9x is equals to 2. Now, if you check the next line, you see that I wrote there are two ways to solve this. Actually, there are many ways to solve simple linear equations, but we are going to be using the second method more. But I'm just trying to show you the first method, which is very convenient also, but it takes a lot of time and sometimes it can get confusing. Okay, now we subtract 25 from both sides. If you notice, we have 25 minus x on your left hand side and 2 on your right hand side. So we want to isolate that unknown, and in isolating it, we'll subtract that number that is at the same side with the unknown. That gives us when you subtract 25 from both sides, you have on the left hand side you'll be left with minus 9, and then on the right hand side you have 2 minus 5, and 2 minus 5 is minus 23. Now each time you reach this point at any equation, you divide both sides by the coefficient of the unknown. But here the coefficient of the unknown is minus 9, so minus 9 divided by both sides. Minus will cancel minus at both sides, and you're left with only positive numbers. Okay, now there is another method I wrote, or we have 25 minus 9x is equals to 2. Okay, now we're going to do what we call collecting like terms. And remember, I once stood in class, whenever a variable crosses this equality sign, its own sign will change. Now move minus 9x to the right hand side. Okay, when we move it, instead of minus 9x, it will now become plus 9x on the right hand side. Now we have 2 on the right hand side. We move this 2 to the left hand side, it becomes minus 2. So we have 25 minus 2 is equals to 9. At the end of the day, you have 23 is equals to 9x. You divide both sides by 9, and you are left with the same answer as it is with the first method. Now let's check another example. Here we have x plus 7 is equals to 19 plus 2x. Now we collect like terms. Okay, x and 2x are alike. Now always remember that any variable that you are carrying and crossing the equality sign, its own sign will change. If I carry plus 2x to the other side, to my left hand side, it becomes minus 2x, not plus 2x anymore. And then if I carry 7 to the other side, it becomes minus 7. Because it is plus on the left hand side, it will be minus on the right hand side. So we have x minus 2x is equals to 19 minus 7. Now you are left with x minus 2x is minus x. It's the same. It's similar to 1 minus 2. But since you have the unknown there, so it will take the same pattern. X minus 2x will be minus x. Is equals to 12. You divide both sides by minus 1. You use minus 1. Each time you are left with an equation like this, where you are just left with minus x, or even if it is minus b or minus a minus y, you have to divide by minus 1. So when you divide both sides by minus 1, this is to enable you cancel the minus that is attached to the unknown. Okay, you're left with x is equals to minus 12, and that's the answer. Now we have example number 3, which is 18 minus 5f is equals to 2f plus 4. Let me see. Yeah, it is plus 4. Now we group like terms. Let's group the unknowns. Now you can either choose to group the unknown on the left hand side or on the right hand side. Anyhow you do it, you will still be correct, but just follow the rule. Okay, you can choose any side you want to group them, but here I said let's group it to the right hand side. So now if you notice, on the left hand side I have minus 5f. I will take it to the right hand side, it will become plus 5f. Now I have plus 4 on the right hand side. If I take it to the left hand side, it becomes minus 4. So at the end of the day, I have 18 minus 4 is equal to 2f plus 5f. And 18 minus 4 we know is 14. 2f plus 5f is equal to 7f. You divide both sides by 7, and you have your f is equals to 2. As simple as that. Okay, now as a prelude, we have equations with brackets here. Now these equations with brackets, if you can recall, last time or beginning, second term, I taught you how to expand brackets. Now the only difference between this example and the previous examples you've been seeing is because of the bracket, and it's simple. All you have to do is expand the bracket and then you follow the rules. Now in expanding brackets, you know that the term outside is multiplied by every term inside the bracket. Okay, now to solve example number 1 here, we'll say 2 multiplied by 4 minus 2 multiplied by x, which is equal to 3 multiplied by 2 minus 3 multiplied by x. So we'll have 2 times 4 is 8, 2 times x is 2x, and which is equal to 6 minus 3x. When we collect like terms, if notice, we have minus 3. When it crosses, it becomes plus. We have minus 3x, sorry. When it crosses the left hand side, it becomes plus 3x. We have 6 and we have 8. 8 is positive on the left hand side. When it crosses, it becomes minus 8. So 3x minus 2x becomes x. Yeah. And then 6 minus 8 is minus 2. It's as simple as that. Now we have another example. We said solve 3 into 3x minus 1 is equals to 4 into x plus 3. Close bracket. Now in solving this, you expand the bracket just as we did in the first example. 3 times 3x is 9x. 3 times minus 1 is minus 3. 4 times x is 4x. 4 times 3 is 12. Now you collect like terms. And in collecting like terms, if you notice, we have 9x minus 4. Because 4 was positive on the right hand side, it came to the left hand side, became negative. Minus 3, we shifted it to the right hand side, it became plus 3. So at the end of the day, we have 9x minus 4x is equals to 12 plus 3. 9x minus 4x is 5x, and 12 plus 3 is 15. You divide both sides by the coefficient of your unknown, which is 5, and you have x is equals to 3. So we'll stop the class here. I'll take questions if you have any question.